Hello everyone, welcome to Policy Engine training session for September 2025. My name is Wahid Ahmadi, Research Associate at Policy Engine. Today I'm gonna present you the firm level analysis, VAT analysis in the UK, and starting from how we generate synthetic data for VAT firm level analysis, and then showing you the results that we have for different policy reform for VAT and our results compared to HMRC reports. And then briefly, I'll show you a dashboard that we have for a static analysis on firm level reforms. Um, yeah, for the first step, I want to show you the methodology that we have for generating synthetic data first. So as you may know, we have two main uh, data sets publicly available for VAT and firm level data. One is ONS and one is HMRC. But the point is that we don't have the disaggregated level data for each firm, and the data that we have for both ONS and HMRC is actually based on some beans, and I will show you what I mean by the beans and uh, the targets that we have only from these data sets. And their starting point is that by just having the HMRC VAT, for example, statistics and liability data, and also for the ONS, how we can generate a synthetic data and how we can reach all of the targets and match all of the moments and get the best synthetic data and representation of the whole economy from the firm perspective. Um, yeah, first I want to show you the distribution of UK firms, the turnover, based on the turnover band and turnover bean that we have from the ONS data set. So basically, the ONS data sets actually reported for each band, turnover band, how many firms do we have? Number of firms based on the turnover band. And you can see that, for example, uh, you can see the most of the, I mean, the highest part in the distribution is from 100K to 250K for the annual turnover. And same as HMRC, uh, the publicly available data set for HMRC for VAT registered firm is actually based on turnover band. So they don't publish anything about uh, disaggregated level of, for example, any panel data or uh, the data connected to each firm. We only have the overall statistics of the uh, firms in the UK. So again, we can have the distribution of the firms or based on turnover band, and you can see the most of the in this data set most of uh the highest part in this distribution is from 1K to 90K. What we want to do is that basically using microdata and try to have a kind of optimization to match the both ONS firm structure and HMRC targets. So by using both of them for the turnover, we want to have a synthetic data and trying to have a micro level data set that we can represent all of the firms in the UK and also match the distributions. So at the end, I will show you how we reach this distribution uh, for the for the distribution of the UK firm for annual turnover for 2024. Uh, Basically, we will generate everything about the industry classification, SIC code, turnover band, employee band, and VAT tax liability. We are expanding this data set by including other columns as well and other features as well. But for now, we only have these kind of information, and we try to match all of the targets from HMRC and ONS to get the best representation of the whole economy. Uh, so just briefly in this distribution, you can see that we have two cliffs. One is related to VAT threshold, which is 90K after 2024. So before 2024, it was 85K. And another cliff is around 150K, which is related to VAT flat rate scheme. It's a scheme for the firms in the UK, so they can actually before I mean before 150K, they actually apply for a flat rate scheme, and they don't need to calculate everything about input output, and they can use a kind of rough approximation about how much they need to pay for the VAT. But after that, after on the right hand side of the 150K, anything above that number, they need to calculate the input output VAT calculation, and get the get the accurate number for the VAT that they need to pay. So in the following, we need to I mean I present to how we are doing the microsim here, and how we are generating the synthetic data, and what is the methodology to reach all of the targets from ONS and HMRC that I showed to you, for example, based on turnover, what we have from those there distributions. Okay, so basically, we started from ONS. What is ONS? ONS says we have the distribution based on the each turnover band. So, but the bands are big here, so we need to just stick to some methodology to can generate the best representation of the firms. Those reach these kind of targets from ONS and HMRC. So we started from ONS, ONS turnover band data, and try to actually generate a kind of distribution uniformly, because we know for each band how many firms ONS has. So we started from uniformly across the band, generate the data, generate the firms, and then adding a kind of noise for the smoothing. We added Gaussian noise. For the smoothing, we applied other smoothing method, and the results are robust. So we can apply different methods, but the results are approximately the same. So basically, the turnover for firm I is kind of generated from this formula, which is T min and T max is actually the boundary of this band, and the uniform distribution here is actually uh, using uh, the normal distribution is for the smoothing parameter here. Um, so this part is for generating turnover, but we added a part for replicating from the turnover, try to reach the input value for each firm as well. So input value, which means the cost of the each firm annually, is generated based on the beta distribution, and we just try to estimate a kind of realistic input-output ratio. They can this factor is actually reflects the fact that different firms have kind of different productivity and cost structure. Um, so basically, we based on industry, we try to replicate based on the beta distribution, try to replicate a R factor here, Ri, and try to get the input based on the Ri multiply turnover that we generated in the last step. So basically, there are some steps in the uh, produces that we have. For example, most firm with input 60 to 95K of turnover are within this generation. And for example, some firms with input greater than turnover, we have some negative VAT liability. So VAT liability, we have some targets from HMRC. So actually, we generated this process, the data from this process, and try to match all of the targets that we have, and get the best representation of the data. Uh, And also we have sector-specific variation based on industry characteristics for the input output. Um, so basically, we started from ONS generating some data, input data, output data. And in this step, we want to match all of the calibration targets. So for example, from the dataset from ONS or HMRC, we know as an example how many firms are within each turnover band. So we need to have a dataset that if we shrink that dataset for based on turnover band, we need to get the approximately the uh, targets that we have from ONS and HMRC, for example. So how we can do that? Basically, the process is the same as what we are doing on the household side. So for the firm level analysis, we consider kind of firm weights here and try to approximate these weights for each firm with a multi-objective loss function. This optimization process assign different importance weights to firms so then at the end when we aggregated these kind of firms based on the column we are considered or based on the feature, then the synthetic population should match all of the official targets from ONS and HMRC simultaneously at the same time. Um, and if we don't calibrate without this calibration step, the synthetic data would not accurately represent the true UK business population. So in this step, we just consider a kind of target matrix formulation. So we construct the target matrix A, which Aij represent the contribution of firm J in target I. So you can assume the target I is kind of uh, in each, as an example, in each turnover band, how many firms do we have, and we can assume that this is the target I, and firm J is the what is the role of this firm to get that target. Okay. Um. So how many targets that we have at the end is basically we have from the HMRC we have 7 targets for turnover bands. For sector counts we have 90 number of targets. So basically um, the data set from HMRC includes the C code and industry for the firm. So we have around 90 targets for the industries, and also from ONS we have 7 number of targets for employment bands. Again, for the liability based on sector from HMRC we have 90 targets, and VAT liability by turnover band we have I mean VAT liability by band, not turnover. The liability band we have 7 number of targets from HMRC. So what is the optimization process? Until now, we just constructed the initial data set from ONS, just generating the data to reach the ONS turnover band, but we want to reach the HMRC and ONS at the same time. So to reach those targets at the same time, we need to represent a weight and then doing the optimization process to calibrate those weights to reach all of the targets. So we can think this process as a kind of fine-tuning of how much each synthetic firm counts in the final population. This is the weight, and we want to play in an optimization process, play with the weights for all of the firms at the same time for all of the targets to get the best result. Um, Also, we can set in our process that some targets, for example, turnover bands, we can say, are more important than others. So we can give some importance weight to each target here. And we run the optimization with the Adam optimizer with the different learning rates and gradient clipping, and we have some kind of dropout uh, process to not to get a bias approximation for the weights, and also having a kind of maximum iterations number. Um, so we run this process with Adam Optimizer, then we can have a kind of final weights for each firm, which at the end we have the best representation of the data that we have reaching the uh, aggregate targets that we have from ONS and HMRC. Um, at the end, what we have is that we can reach from these two distribution, one from HMRC, one from ONS, use both of them to get this nice distribution about the turnover of the firms in the UK. So basically, uh, we need, as I mentioned, we need a kind of smoothing parameter here. Otherwise, we'll get a kind of weird shape of because the bands are big here, and we if we don't use any smoothing process here, then we couldn't get a good shape of the distribution. So, um, yeah, then there is a kind of information in a ONS that, for example, all of the data that we have, all of the statistics that we have based on turnover band in HMRC, they are related to uh, firm registered VAT. So basically, we need another kind of parameter to calculate the probability of VAT registered firm. So the logic is that if your company doesn't reach VAT threshold, which is 90K for now, you don't need to, it's a voluntary stuff to just do the VAT registration. But after VAT threshold, which is 90K, you have to do that, and it's the obligation. Uh, so the numbers of firms in each turnover band for HMRC uh, actually they are all VAT registered, but for ONS is not. So if you are using both of them, we actually have a kind of column for probability of registration, and we can calculate that how the ONS, which is includes all of the firms, for the HMRC, uh, we only have the firm VAT registered one. So if we after reaching 90K, anything above 90K, so the probability of registration is 1 because all of them needs to register for VAT. But before that, we can actually assign a probability for each firm to get registered through sorry for the 85K, it should be 90K all of the places here. Um so we can actually assign a kind of probability here and get a I just the estimation is that uh, for 0 to 90K should be 90K here is a kind of I assume a Bernoulli distribution for the probability of VAT registration, but after 90K it should be 1. Why do we use Bernoulli distribution? Because voluntary VAT registration is a binary random choice. So the best distribution that we can represent is Bernoulli. Um, the probability that any given firm below the threshold would voluntarily register to VAT is R probability of R here. To calibrate the match the observed population proportion of voluntary registered in the HMRC data. Um, yeah, same process as the turnover band we can have for the employment assignments. So basically, we have different employment band for example, small firms like 0 to 4, I use the uniform distribution, and for the other one, beta distribution plus a 250. Um, Employment, I use log normal distribution because if you check some of the result from economic literature, we can see that how is the distribution of uh, employment for small size companies and big size. So big size companies are basically follow a kind of approximation. Their approximation follows a kind of log normal distribution for the employment. So for more than 250 employment, I just generated the employment size for each firm based on log normal distribution. Um, how we calibrate, I show that how we do the optimization process. Then at the end, when we have the weights and simultaneously uh, try to optimize based on the loss function that calculates all of the targets and try to minimize the error. Then we will have the final weights for all of the numbers that we have. For example, turnover, employment size, what is the industry C code, for example. Then uh, we have a kind of metrics to see how good we are doing on the targets that we have. For example, for turnover band, I just showed some kind of targets that we have for each. For example, turnover band, we have seven, and the numbers for the other. Then based on these metrics, I mean, we can calculate the accuracy of calculation uh, and try to see what is the accuracy and how good we are in getting the targets that we have. So this is a kind of first step to just generate the synthetic data for firm level analysis. We can use other things. For example, our plan is to just use the input output and what is the effective tax rate on based on the input and output uh, and so on. So uh, in the future, we need to work on that. And again, for example, we can have a good, maybe better approximation on a category of the firms. For example, we can generate um, based on age here. I mean, age of the company, and we did for the C code here, and maybe we can have another uh, kind of categorization for the firms in the future. But the process is the same. We are doing the same thing for the household side in Policy Engine as well. Uh, so after that, if there is no question, uh, I want to show you a blog post that we have for just getting the initial result based on uh, the synthetic data that we generated. So there is a kind of debate on what is the effect of changing the VAT threshold with respect to revenue generated for the government. Um, and there is a kind of discussion about should we increase or decrease, and what is the effect of these changes on the growth of the whole economy. Uh, the first step is that basically I want to show you a comparison of our results to the HMRC projections. So for now, we just assume there is no behavior responses for the firms, which we are this is that we are working on that, and in the near future we can talk about that in detail. But for now, we just assume there is a with a static assumption, and there is no behavior response assumptions here. So for now, let's assume that on the static framework, we want to see uh, our revenue impacts estimation and compared to HMRC data. So HMRC has a kind of uh, report about if we change the policy and if we freeze the, for example, freeze the VAT threshold to 90K, what happened? And if we, for example, trying to operate with other part of the economy, uh, what happened to that? So, for example, in their report, they just basically for 2024, 25, their baseline is 85K, and the policy that they proposed at that time was 90K. You can see that, for example, in their report, which the link is here, you can find it in Policy Engine Research, then you can just click that. For example, for 2027, 28, their baseline is 89K, and the policy that they proposed at that time was 90K. You can see that our results is basically match the uh, statistics that the HMRC reported. So, in that sense, we can say that the synthetic generated data that we uh, explained in the previous session, in the previous part, we actually, with those data, we can get a good approximation like what HMRC report. Um, yeah, and then about the debate and about the proposal. So basically, we want to show if we change the VAT threshold from 90K, which is the current rate, to anything from 70K to 120K. What happened to the tax revenue for the government? So first step is just to generate a, under a static framework, just to generate the tax revenue based on different assumptions for the registration threshold. And you can see that if we actually uh, have a lower threshold like 80K, 70K, the revenue generated is actually more than what we have as a baseline here, 90K currently. Um, and also, we reported something else, which is the how many firms are affected if we change the VAT threshold. So VAT threshold is right now is 90K, and if we change it to 80K, 70K, how many firms are affected, and the firms need to actually pay VAT, how they change. So we expect that the line should be decreasing here. Um, yeah, and um, for the future step, we just need to include the behavioral assumptions here. So we kind of have a need to have a kind of micro model on the firm level decision and how they decide about uh, hedging their risks and the bunching stuff and how they decide to get a, for example, be above uh, threshold or below the threshold, VAT threshold. So we are working on that in the near future. We can have a session on that. The last thing that I want to show you is that we basically created a kind of dashboard for VAT policy simulation on the static format. So in this dashboard, you can easily uh, have a different, see the result under different reforms. So basically the baseline is 90K for the current year. Let's change it to, if we want to have 100K as a threshold for a proposal. Uh, and then if you press the analyze reform, let's see what happened. So we expect that the revenue should be negative. Uh, yeah, and you can see the firm affected number uh, over the years. And also we actually use a kind of uh, operating by the, let me show you. Uh, operating by the aging here. Let me, okay. Um, yeah, we have some growth factor here based on the OBR retail price index format. So we actually calculate the kind of growth number for the firms here. But yeah, we can see the revenue impact based on the year, and also based on uh, impact by the revenue band here. Um, and also you can actually have your custom tapper. So maybe you want to uh, just to mention the VAT tax rate is 20%. So assume that you want to not have a kind of a step function as a VAT threshold, and you want to have a kind of smoothing function and try to starting from uh 70K. 70K is zero tax rate, and then you want to have a smoothing function until tapper end is we can say 110K. So at the 110K you'll have 20% tax rate. And let's see what happens if you have a smoothing function. What is the impact? Uh, okay. Then you can see what is the impact based on the revenue generation over the years, and also firm affected in each year. So I mean, that's all I wanted to show you for the VAT. Uh, VAT modeling as a summary, we started from how we generate synthetic data and uh, how we what is the methodology to reach all of the targets from ONS and HMRC. And then I showed you a kind of example of our results compared to HMRC targets and HMRC statistics. I show you uh, the blog post that we have, and also discussing the tool and a quick dashboard that we have to actually you can apply any reforms based on VAT and see the budgetary impact and distributional analysis based on the turnover band. Um, yeah, that's it. If you have any question, happy to answer that.